there's not that much to probabilities. It involves working with fractions is the most straightforward, easy way to do it. But fortunately, just like other story problems, you can often switch back and forth between fractions and decimal. Whichever makes it easier for you to work with, that's what we want to do. Again, I don't want to give you the impression that there's only one right way of doing these things. I can certainly help you from my experience and tell you ways that I recommend. But ultimately, through your practice work, I want you to try out 2 or 3 different methods that there are to do something and determine which one works best for you. And I mean, I always say this, but there are 3 parts of coming up with a good method of solving a problem. First of all is that it reliably gives you the right answer, so that when you use that method, you get the right answer every time. Second is that it doesn't take too terribly long to do it. This test is not just about getting right answers, it's about getting right answers in the appropriate amount of time. And so you can sort of win the battle and lose the war if you get the right answer, but it takes you 3 times as long as it should. And of course, the friendly folks at GMAT are going to try to do that to you from time to time. So you want to be aware of how much time you're spending on questions so that you don't let them get you to take forever doing it. So you want to get the right answer, you want to get the right answer in a relatively short amount of time. And then the third, if you can help it, ideally, you don't want to spend any more effort on any one question than you have to, because you start out the test with a certain amount of mental energy, and you don't want to use up more energy on a question than it's worth early on in the test, just to find yourself just tired or exhausted when it comes down towards the end of the test. So whichever method a particular question calls for, that's when, in probabilities here, that's when you're going to want to use either fractions or decimal. You want to be comfortable using either one. So there are just a handful of ideas in probabilities, and I don't even like that term probabilities because that's misleading. That would tend to indicate that something is probable, that it's probably going to happen. And no, what we're really looking at is possibilities. And so that's why I switch between the words, what are the chances of this happening? What's the likelihood? What's the probability? I mean, you never know whether something is going to be probable, which means more than 50% likely to happen, or whether something has a 1 in 6 chance of happening. So the basic idea, and of course this is simple. I'm using simple terms, and it'll get more complicated. Don't worry about that. But if you'll scroll down about 1 inch on the page, the way you come up with a probability is that we, as budding scientists and mathematicians, we want to conduct an experiment. And so we're going to ask ourselves, how many possible ways could this thing happen? How many different results could this thing produce? And then, because we want to explore something, how many ways could we possibly get our desired outcome, the thing that we want to test, the thing that we want to happen? And that gives us a fraction, that gives us a ratio, that gives us a percentage. If we flip a coin, just a second, please. Okay. If we flip a coin, how many possible outcomes are there? 2. And I want to know the chances of that coin coming up heads. Well, there's only one way that it can come up heads out of 2 possible choices. So, as a fraction, that's 1 out of 2. That's exactly the same thing as a ratio of 1 to 2. That's exactly the same as saying, as a decimal, there's a 0.5 chance of that happening, which is exactly the same thing as saying there's a 50% chance of a coin coming up heads when I flip it. Whichever one of those different ways of writing that down or thinking about it works for you for a particular question, then that's the one you should use. And again, let me repeat that the way that I put this course together, it's sort of bad news for you, but it's not meant to be that you just come to class and then you're going to be ready to take the test tomorrow. Okay, we're going to talk about the ideas, the concepts. You're going to ask questions. I'm going to do my darndest to answer them. And then after that, over the course of the next few days, the course of the next week, as you do practice questions on these exact same topics, then you'll start to really fill in the blanks and become familiar with become comfortable with the material yourself. And that's between that 1-2 process, that's how you're going to become well prepared for the test. Right. I'm pleased that someone actually brought that up, because I always feel silly. Okay, so Thomas, you're the wise guy in the class, right?
I've always been.
Yeah, that's right. I've always said that about you. That Thomas, he's a wise guy. In reality, what's the third possible outcome?
Lands on its side, or you lose the coin?
That's 2 possibilities. 1 is that it would land on its side. 3, if it doesn't come down for some reason. On the actual test, it's not that clever. So for the purposes of this exam, we only want to think up to a certain point and then no further. This test, as far as it's concerned, there are only 2 possible outcomes. I mean, when we talk about rolling a die, well, theoretically, it could land on a point, and that would be a 7th, or well, that would be 12 possibilities then. Or it might not come down because someone grabbed it or something, so then you'd have 13 possibilities. But you'll start to lose your mind quickly at that point. So this test is not that clever. And so you don't have to think that nitpicky away. I mean, and that's how your practice will give you an accurate feel for just how tricky this test is and how tricky it isn't. Does that make sense?
Yeah, that makes sense.
Cool. I'm glad you brought that up before I did, because normally I bring that up. No, this is not the real world. You don't have to count the chances of it landing on its side. And no one said I didn't want to, but I'm glad you brought it up first. Okay, so again, definitely don't let them get you to make things more complicated than they need to be. This test works on a certain level and not beyond that. So as far as we're concerned, there are 2 possible outcomes when you flip a coin, heads or tails. And you can express it any one of those different ways there. Now, this one is going to be maybe the most important concept when it comes to probabilities, is when you have a series of events. You have at least 2 events, or you could have any number of events. When that happens, say that you roll 2 dice. For the purposes of this test, always imagine that one of them happens first, even if it's just a split second before the other. Always imagine that one of them happens first, and then one of them happens second. And so here we have the idea of independent events and dependent events. Starts to make it easy when we think of it as one of them always has to happen first. Then the first event is always independent. That is, nothing has happened yet that's going to have an impact on the outcome. If we're flipping a coin, we have exactly a 50-50 chance of getting whichever outcome we're looking at. If we're rolling a die, we have all 6 of our different possibilities open to us. So the first event is always independent. The thing that you always have to ask yourself when it comes to the second or follow-on events is the outcome of this thing affected in some way by the first event that just happened? And if it is affected in some way by the first event, then that's a dependent event. Its outcome depends to some extent on what happened on the first event. If no, the first event has no impact whatsoever on the second, then it's an independent event because it also has all of its possibilities open to it. Fairly simple concept, but important because, again, on these math questions, your job is not necessarily to calculate out the answer. It's to select the correct answer from the choices that you're given. And so often you can cut down on the answer choices until you get two answer choices that seem plausible. And you'll often find that one of those would be the answer you would get if the events were both independent, and the other answer is the one that you would get if the two answers are independent. And that's when you have to really ask yourself the question logically, does the result of the first event have some bearing on the second event? So let's look at two possible setups. So please, write this down in your notes, think about it, work it over. If I'm flipping a coin, it's perfectly balanced, heads, tails, and the coin has come up heads 100 times in a row, what are the chances of that coin coming up heads on the next flip? Give me your answer in the chat box. Right, I don't think anybody was fooled by that, which is good. Probabilities come in really, really, really handy if you're an enthusiast of casino games or card games or something. But this is no place whatsoever for superstition. And the roulette wheel in a Vegas casino, you can probably assume the thing is perfectly balanced. It's perfectly randomized. And they say the wheel has no memory. If it came up black on the last spin, the chances are exactly the same this next time that it'll come up black. No more, no less. So if I flip a coin 100 times in a row, and given that it's perfectly balanced and nothing funny about it, I still don't know why in Vegas they won't let you bring your own dice to play craps. I mean, that would just be accommodating if you could bring your own dice. But they don't let you do that. I'm not really sure why. Well, right there, you see, that's how superstition or some kind of impression would steer you wrong. One student said, well, then I'd bet on it coming up tails the next time. You might think that. You might also say, well, that coin is rigged. It comes up head every single time. Based on past experience, that would tell me it's going to come up heads the next time. A different way of thinking about it, sort of non-scientifically, would be, well, if it's come up heads that many times, then the luck has got to change, so it's got to come up tails. Well, I just made two arguments that are completely contradictory to each other. And the truth is that each one of those 100 throws was an independent event. And the 101st throw is an independent event. The chance of it coming up heads are 50-50. It might come up heads, it might come up tails. We don't know. Now, what are the chances of a coin coming up heads 101 times in a row? Give or take. The chances would be extremely small, because now, in that case, the first event, that was independent. That's always independent. Every one of the following chances, every one of the following outcomes would be a dependent event. They would depend on the thing having come up heads the time before. And so I like to look at it with probabilities as thinking about how demanding you're being of your outcomes. And the more and more demanding you get, I want it to come up heads the first time, and then I want it to come up heads the second time, and then I want it to come up heads the third time. Well, then we multiply. And that's where it helps me to look at it as decimal 0.5. Okay, the chance of it coming up heads in the first row were 0.5. The second time, times 0.5. Two numbers that are smaller than 1 multiplied together will give you a number that's smaller than 1, even smaller than 1. And so 0.5 times 0.5 times 0.5, 101 times. That's going to give you an extremely small number because those are dependent events. So if you were going to pick out a cat from the animal shelter, and you'd say, well, I think I'd like a female cat. Okay, let's just assume that those odds are 50-50. Half the cats and kittens are female, and half of them are male. Okay, so I got a 50-50 chance of getting a female. And I'd like a gray cat. Well, let's say those chances are 1 in 4. I don't add those numbers together. I'm being more demanding. I want a female cat and a gray cat. So now those chances so far are 0.5 times 0.25. And then I say I want a kitten rather than an adult. Let's say that's 50-50. Okay, we multiply again. We don't add because I'm being more demanding. The chances of me getting the outcome that I want are smaller and smaller and smaller. This is just a reflection of nature. But if I say I'd be willing to take a male cat or a female cat, well then that's 0.5 plus 0.5. Again, here we don't consider the possibility of having a hermaphrodite cat at the animal shelter. That's getting too complicated on this test. Then that means I have a 100% chance of getting what I want because I'm willing to be more inclusive or more open-minded. I'm willing to accept this or that. Then I add. And remember that as the convention here in probabilities, the idea of 100% likelihood of something happening is just equal to the number 1. When we're talking about probabilities, the number 1 means 100%. And so if the chances are 50-50 of getting a male and 50-50 of getting a male plus 50-50 of getting a female, that adds up to 1. That means certainty. And so, okay, again, the first event is always independent because you always have all your possibilities open. The only question to ask yourself is, when I do the second thing, is that outcome going to be affected by the first? If it is, then that becomes a dependent event. If not, then it's an independent event. And dependent events, that number will get smaller and smaller and very quickly. And that's the tip-off very often, that depending on whether the event's going to be dependent or independent, you're going to get a number that's a relatively generous possibility of something happening versus a very, very small number because it's very